So far, you've learned about 3 named types: enumeration, structures, and classes. There's just one more to learn about: protocols. You've already used protocols. Case iterable was a protocol that we used a few times on enumerations. And if you worked through your first and second SwiftUI app courses, you definitely used the view protocol. But you haven't written your own protocols yet. We'll fix that in this episode. Now, this is actually a deep topic, and we can't cover everything about protocols in this course. But now that you know about class inheritance, we can go over the similarity between that concept and protocols. Then, if you're interested, you can do more research into advanced usage of protocols. Our book, Swift Apprentice, has 2 chapters on protocols, which cover some topics not covered in this course. Now let's compare class inheritance and protocols. This starter code begins with what we just wrote in the challenge on initializers. Animal is what you'd call an abstract class. It's not meant to be instantiated directly. You can tell that because the speak method doesn't do anything. It just requires that all subclasses can speak. It's assumed you'll override that method to provide something appropriate for each concrete animal type, like dog and cat. Let's turn animal into a protocol, and we'll see that abstract classes and protocols have a lot in common. The easiest way to begin with that will be to comment out everything within animal. You'll get errors, but we'll deal with them. Then change the keyword class to protocol. Now let's deal with how to use name with animal being a protocol. Change the let to var, and after the type of name, string, in curly braces, put the keyword get. Protocols define a common set of properties and behaviors, but unlike with classes, in the definition of a protocol, you're only listing requirements and not implementations. So here, we're saying that for every animal, you can get its name, but we're not saying anything about how that's done. Name could be a computed property or stored. That's up to the animal types themselves. You could also add set within the braces if you wanted to enforce mutability for the animals' names, but we don't. Dog and cat need stored properties for their names. So unfortunately, unlike with a superclass, we have to define that storage individually for both dog and cat. Notice how we used let, as animal originally did, even though the protocol uses the keyword var. Let doesn't show up in protocols, but a constant counts as a get-only property as far as a protocol is concerned. For the initializer requirement, it's going to be the same sort of situation. We won't be able to use an initializer body from animal. But we can still enforce the requirement of having a certain initializer by putting the signature of that initializer in the protocol. This required init body is just what we need for cat, so cut and paste it into cat. And for dog, we have to assign directly to name as well because there's no such thing as super anymore. Protocols are not superclasses. Dog and cat are actually both base classes now. For the last requirement that an animal can speak, the necessary change is the smallest so far. Uncommenting what we had, we see that protocol methods don't and can't have bodies, so we delete it. And now we're even more clearly expressing that an animal has to be able to speak than we were before. What we don't do is use the override keyword anymore. That's only for subclassing. For a moment, let's comment out cat's speak method. And you'll see that cat does not conform to animal. There are two parts to using protocols with your types. The first part is adopting a protocol, where you declare that a type conforms to a protocol. That uses the same syntax as class inheritance. You follow the name of the type with a colon and the name of the protocol you want to conform to. In our case, because animal used to be dog and cat superclass, we didn't need to make any changes here. Unlike with class inheritance, you can adopt protocols using extensions. You'll see that technique used a lot for organizational purposes. To actually conform to a protocol means satisfying all of its requirements. According to our definition, if a type doesn't have a name property, an initializer that accepts a name, and a speak method, it can't be an animal. But otherwise it can. We're almost done getting rid of the errors. What the last ones are telling us is that because animal is no longer a superclass of dog and cat, Swift doesn't know what the elements in the array have in common, but we can help out with explicit typing. And now we can iterate through our animals, just like when animal was a superclass, and each one of them speaks in their own way. What you can't do now is instantiate an animal directly. But when animal was a class, it wasn't meant to be instantiated, so this is just fine.